All right, we're back for numbers 4, 5, and 6. These are non-calculator problems. Again, you're going to have your calculator on your test, so you won't have to worry about that aspect of this, but you'll see that on a lot of these, you're going to have to show your work. So I'm going to focus on the manual side of things. Also, one of these problems was an area problem. I put it on there. You're not going to have to know area, but I had already I had posted that. In the future, I will eliminate all the area problems and insert other stuff. But there were a couple things that showed up on that area problem that I wanted you to see. So I'm including that as well, so you can look at that thing about maximizing the vertical distance, as well as some of the integration. You'll see that in a moment. Hope you are doing well. Miss seeing you guys, and hopefully you're following along with me and getting ready. I think you'll do really well if you continue in this way. All right, check out 4, 5, and 6. Okay, number 4, guys. I can almost promise you're going to see a differential equation problem on there. I just feel it is so important to AP Cal, being able to solve a differential equation, understand differential equations, what they mean. It's just such a big deal. I'd be shocked if you did not see this in some manner. And in a 45-minute question, it may represent a fifth of the points you get, maybe even more. I don't know, but you're going to have to know this. So the first question you're seeing is they're giving you a differential equation and they're asking you to sketch the slope field. So bottom line, guys, slope is equal to that. So if I want to know the slope of something, I'm just going to have to go through each of these individual points and plug the points in there. And I'll do that for a couple, like this point that's at 1, 0. If I plug a 1 there and a 0 there, I get 1 times -1 is -1/4. So remember how you did slopes? You almost have to think 1/4 would be either up 1, left 4, which puts you out here, or you could think down 1 to the right 4. Well, because I didn't even have 4 spaces to go over, I thought, well, up 1 over 4 is the same thing as up a half over 2. So I tried to make my line resemble that. Now, they're not going to be super anal about that. As long as it's really flat, I think you're okay. I'm going to do another couple at 1, 3. If I plug a 1 and a 3 in there, I get 1 times 2 is 2 over 4, which is a half. So for right here, I'm going to go up 1 over 2 and sketch a line that looks like that. Or I could go down 1 over 2 and sketch a line that looks like that, but just sketch that part. If it's hard for you to visualize that, then just instead of going down 1 over 2, go down a half over 1, and it's easier to simplify. So just kind of reduce each part by a half, or do a half of each part, and it's kind of easier to see. And then you'll notice on all of these, the slopes were 0. And that happens when either y is 1, the whole top part 0. So you can see that. These are all places where the y was 1, I got zeros, or also where x is 0. And x is 0 all up and down through here, right? 0, 0, 0, 1, 0, 2, 0, 3. So all of these were 0. You got 1 point. About to sneeze. Sorry. You got 1 point for doing all of these. Don't circle them like I did. But you got 1 point for that, and then all the other ones you got a point. So it's possible to get 2 points for that slope field. And it's possible to get less than 2 points and even halves. All right, part B. It says, let y equal the particular solution. So what they gave me was a dy dx. I want the y, the actual original equation. And to do that, well, I don't want that right here, but it says, but eventually I will on part C. But on this one, they're saying, let y be that particular solution that went through the point 1, 3. It says write an equation for the line tangent to the graph of that y equals f. So I don't want the y equals f yet, the particular solution. I want the line tangent to it. So what do I need for a line tangent to the curve? I need a point. They gave that to me, 1, 3. I can go ahead and plug that in, x minus 1, y minus 3. And I need a slope. Guys, do not plug the slope equation, x, y minus 1 over 4 in there. Don't do it. You're not going to get that half point. All right, you want the actual slope at the point 1, 3. So I'm going to plug 1 in there for x, 3 in there for y, and I get 1/2. That's what goes right here. That's what you get your 1 point for. Okay, now I'm going to use this tangent line to approximate the function at 1.4. Because you remember, the tangent line is going to be touching the graph at 1, 3, but since 1.4 is really close to 1, the value of y on the tangent line is probably pretty close to the value of y on the function that I don't know yet. And even if I did know it, don't plug 1.4 in there. I want the approximation. So just plug 1.4 in there. Now, guys, you don't have to solve for y. You don't have to take that, multiply it in, and add the 3 over and get the function and then plug 1.4 in. You don't have to do that. You can just show that, look, just say something like at x equal 1.4 and plug that in to your graph. There it is, x equals 1.4, and then just show the process to get 3.2. And 3.2 is what you got that last point for. So far you're 4 points into this question, and they really haven't challenged you a whole lot yet. But expect to see a tangent line approximation problem. Expect to see a slope field, perhaps. They even put a lesson on the AP website on slope fields because a lot of people hadn't gotten to it yet at this point in the year. We had. A lot of people are slower than us, or maybe they start later in the year and hadn't gotten to it. They even put lessons on this. So they did that for a reason. I would definitely know these. And then they also have a lesson on how to solve a differential equation. Guys, finding a particular solution is the way they could word it. Finding a general solution is how they could word it. They could say, find the function y. Because remember, they gave you dy dx, that's the slope. I want to know y, the actual function. How do I go from a slope back to the original one? I integrate it. How do I integrate it? I separate my variables. So you'll see that I took my dx part and either multiplied both sides by it or slid it up here. And then I took the y minus 1 that was on top. Remember, this was x times y minus 1 over 4. I took the y minus 1 on top and divided by it on both sides or slid it down there. So now that I have my separation of variables, which is a point, you got a point just for doing that, I integrate both sides. Now, that is the same thing as the integral of 1/4 x dx. So I can just keep the 1/4 and integrate the x, which is x squared over 2. Don't forget a plus c. If you forget the plus c, you don't get any more points, okay? The max you could get on this was 3 out of 5, max, right? But you got a 1 point for separating, 1 point for doing that integral, 1/2 point for the c. And then you got to integrate this. Guys, that's not a rule. 1 over y minus 1 is not a rule. So technically, I have to say u is y minus 1, du is 1 dy, and then I got to change that to u, that to du, and now I have 1 over u, which is the natural log of the absolute value of u. Plug it back in. So I didn't show all those steps because all AP gives you credit for is that. Make sure you're careful with that. If I would have made this 3y minus 1, then I would have ended up having a 3 dy there and a 1/3 on the outside. Be careful about that and the u substitution. All right, so now I got a point for that. Now at this point, I've gotten 3.5 of the possible 5 points, but I want to get those last little bits. So you got 1 more half point for plugging a 1, 3 in. Now I don't want to plug a 3 there and a 1 there because it's a mess. So what I'm going to do is get rid of this ln by e'ing both sides, right? Exponentiating with e, and that cancels out the n. And remember, if there's a number in front of my ln, like right here, I've got to divide it over before I e it, right? You can't e a number ln, just an ln, right? That cancels, and then remember what you can do on exponential functions? With e, I can swing the c out to the front. Now this is a much better place. In fact, I even got rid of the absolute value because the absolute value means plus or minus c, and c eats it, right? So at this point, I added the 1 over, and I'm ready to plug the 1, 3 in. I could have plugged the 1, 3 in right here if I wanted to. I just chose to plug it in right here. And when I do that, a 1 in there and a 3 in there, you can see it. I get ce to the 1/8 plus 1. So I subtracted 1, and I divided by e to the 1/8. And if I divide by e to the 1/8, I get 2 over e to the 1/8, which you're welcome to use as your c. You're welcome to write 2 over e to the 1/8 right here, okay? So I did that. I just chose to bring the e to the 1/8 up and make it a negative 1/8. So that's my c value. I then plug the c value back in right there, and I'm done. On the free response, you're welcome to stop right there. I chose, if you look at the rest of my work, to go like bases, add exponents, and you can see that I did that, and then I even found a common denominator and made it look real pretty. You don't have to do any of that. This is great on free response. So you got a half a point for showing. I would encourage you to show them you're plugging a 1, 3 in, because even if you plugged it in right here or even right up here, if you plug a 1, 3 in and say, hey, look, I'm plugging the 1, 3 in, look at me, you get that extra half point. And at that point, you've gotten 4 or 5, even if you don't get it solved correctly. All right? Okay, and then, so that's number 4. Number 5, this was the volume question and the area question. So I'm gonna skip over the whole thinking on area because it's really not necessary. But as you know, area of R would be the height, top minus bottom, integrate from 0 to 9 dx, and then you just plug the root x and the x root 3 in there. Now, so you got a point for doing area right there, top minus bottom. So what I wanna do is focus on the calculus from that point on. So how do I integrate this? Well, because it's a minus, I can integrate each part. So I'm going to integrate x to the 1/2 by adding a 1 and dividing by the new 3/2, which is multiplying by 2/3. And then here, this is the same thing as a 1/3 x. So I'm going to add a 1 to that, gives me x squared, divide by a 2, gives me a 1/3 and a 2 on the bottom, which makes it be 6. And then I draw that line, guys. When you do this integration, draw the line, put the 0 and the 9 on there. Your integral's gone because you've integrated. Okay? You have to say this. You got a point for that, right? And then if you plug a 9 in there and then plug a 0 in there, you either got a point for this or a point for this. But if you don't show either of those and all you have is an answer, you don't get that point. So guys, please show this right here. Just show it. It's so easy to do. Take a step, show that integral and the 0, 9 in there. All right, now I got to clean it up. So what does the 2 mean? 2 means square root. So the square root of the 9 is a 3. 3 cubed is a 27. Cancel, 18. And right here, the 9 squared is 81/6. And then the 0 in here greatly makes everything 0. So I don't have to worry about that. So all I got to worry about now after canceling that is going 18 minus this. And 18 minus 13.5 is 4.5. You'll have a calculator. That should not be a problem. 4.5 or 9/2. Okay, number B asked again for let me see, it says expression that gives the volume of a solid when I rotate it about y equals 4. We don't have to do rotational volume on this test, but if we were, real quickly, I go I go axis minus outer squared, pi that squared from 0 to 9. Okay, so, and how do I know it's 0 to 9? Because that intersects right there at 9. I could set these two functions equal to each other. It probably actually told me, yeah, it did. It told me it was at 9 right there. So 0 to 9. So pi that squared. And then I want to get rid of the HOLE. That was the WHOLE. The HOLE would be axis minus inner. So there's my axis minus inner, pi that squared dx 0 to 9, and I subtract. But we're not going to have to do that on this test. So moving on, C. Now this is what I did want to focus on. C said, what's the maximum vertical distance between G and H? Now, think about it. What's the max? I can look at it and say, oh, it's about right here. That's the maximum vertical distance. Well, how would I find that? I'm taking the y value of the G, which is all of that, and I'm subtracting the y value of the H, which is that part. And that would give me that. So the distance between that is just the y minus y. Now think for a second. If the distance is y minus y, then how do I find the max distance? Well, the max occurs at the endpoints or the critical numbers of the derivative. Remember, maximization? So I take the derivative of that, set it equal to 0 or dne. So if d is that minus that, then the derivative of g is the derivative of that minus the derivative of that. Well, what's the derivative of this? Double it on the bottom. Derivative of x is 1 on the top. What's the derivative of negative 1/3 x? Negative 1/3. Set it equal to 0 or dne. Now, actually, it's equal to 0 at 9/4. I'll walk you through the algebra. It's actually undefined at x equals 0. But since that was an endpoint, I didn't bother with that. Okay, so I'm gonna check it at the endpoint, but I didn't have to bother finding out that it was at x. You can see that it's undefined at x equals 0, but that's also an endpoint. So here we go. How do I set this equal to 0? Well, I'm just gonna add 1/3. I'm going to cross multiply. I'm going to divide by 2, and then I'm going to square both sides. So I get 9/4. So I need to take the endpoints, which are 0 and what? Maximum total distance between these two functions, between 0 and 16. So I need to take the endpoints, which are 0 and 16, and I need to take the 9/4, and I need to plug those back into the distance formula. Now, what's the distance formula? It's not the derivative, it's the distance formula. So I'm going to plug a 0 in there, and I do that, and I get 0. I'm going to plug a 9/2 in there, and I do that, and I get 3/2 minus, to divide by a 3, I multiply by a 1/3, and I get 9/12, which is 3/2 minus 3/4, which is 3/4. Okay, and then I need to find the distance there, and I plug a 16 in there, and I get 4 minus 5 1/3, which is -4/3. Now it says distance. The negative distance is still a distance, right? Distance is like absolute value of everything. So the maximum distance actually was not 3/4, it was -4/3 when you take the absolute value. These are 4/3 apart. So that was a little tricky. And you got 1 point for telling me that it's 4/3 and for showing that setup. My guess is you probably got a 1/2 point for checking the critical number and the endpoints, and then a 1/2 point for being right. All right, but look, you got 1 point for saying I need to take the derivative of the distance between them. If you wrote that right there and set it equal to 0, you got a point. That right there set equal to 0. You got to have it equal to 0. Even if you know it and you actually did this correctly, you won't get the point if you get this. Even though you thought it, you have to write the derivative equals 0 because that's how you maximize something. Set it equal to 0 D&E. Okay, so that's number 5. And then lastly, number 6 says, all right, this is G. It gave you just a regular old function, a little bit weird, but whatever. And then it says f is the integral of the G function from 0 to some other number as long as x is positive. Now it says find f of 26. Well, you literally got a point, which is crazy to me. F of 26 would be just plug a 26 right there. So literally I went from 0 to 26 of the G function. Okay, you might have gotten a point for that, but they said you get 1 point for actually taking that G function, plugging it in there and plugging a 26. That you got a point for. Okay, now how do I find that? Well, I've got to integrate it. Well, how do I integrate this? This is not a rule. Well, let's try to make it one. The 4 can be brought out to the outside. All right, that leaves me with something to the -2/3. Well, if it was just u to the -2/3, I could use a power rule. So let's let that be u. That means du is dx. So if all of that's u and all of that's du, then I just get this. Because the 4 I can just swing to the outside. So what's the integral of u to the blah? I add 1 to that and I get a 1/3. I divide by a 1/3, which is multiplying by a 3. I carry the 4 over. I draw the line 0 to 26. The integral goes away. And now I can plug my u back in there. And notice I took the 4 and 3 and made it 12. Okay, so that's all I have to do right there. If you do that correctly, you just got 2 of your 3 points. And then now all you got to do is plug the 26 in to get that. Well, you can just write it like this. Plug the 0 in and it gives you 12 times 1 to the 1/3, right? And then you got to clean it up. That's a 27. What's the cube root of the 27? It's 3, and then 3 to the first is 3. 3 times 12 is 36. What's the cube root of 1? 1. 1 to the first is 1. 1 times 12 is 12. Subtract them and you get 24, and that's your last point. Okay? Guys, be careful. Show your setup. You can get points this way pretty well. All right, part B. Determine the concavity. Now, what do you know about concavity? Concavity is found through the second derivative. And I want the concavity of f. All right, so I need to take the second derivative of that f and determine what is the concavity for x values that are positive. So let's hold off on that yet, and let's just find the second derivative of that f. Well, we can look up in part 6a or part 6 in CF. So I need to take the derivative of that f right here 2 times, twice. So here's the first derivative. The first derivative of f is the derivative of the f function. So what happens when I'm taking the derivative of an integral? Guys, that's the second fundamental theorem. So how's that work? The derivative cancels out the integral. I ignore the number down the bottom. I plug the x in, which gives me no change. And then I multiply by the derivative of x, which is 1. You got 1 point for finding the first derivative. right? Then I take that right here to find the second derivative. I'm going to take the derivative of that. So what's the derivative of this? Negative 2/3 times 4 is negative 8/3. Decrease that by 1, so subtract a 3/3 gives me negative 5/3. Copy the blah down, and then take the derivative of the inside part, which is 1 times 1. So that is my second derivative, and I'm fine to leave it like that for the second derivative. But that's going to be hard to think through. So here's what I did. To think about, what do I get for the second derivative when x is positive? So I moved this down to the bottom so I'd have a positive exponent, left the 8 on top, put the 3 on the bottom, left the negative out there. Now I have a question. What is this fraction's value going to be? This fraction represents the second derivative. What's it going to be when x values are positive? Well, think about it. As long as my x is positive, when I cube root it, it's positive. When I raise it to the 5th power, it's positive. When I multiply it by 3, it's positive. When I divide it into 8, it's still positive. But so it's always positive until what? That. And that makes all of them negative. So it does not matter what you plug in for x. Anything bigger than 0, because of the final negative, means that your second derivative is negative. So for any value of x bigger than 0, which is what I'm using, my second derivative is forced to be negative. And if it's forced to be negative, then the function f is concave down because the second derivative is negative. And that's what you got your last point for. All right, flipping it over. Last part, C says, if h is this function, find the minimum of h. Well, guys, how do I find mins? This is not relative min, this is a min. Mins are found when the derivative of h is either 0 or dne, right? Those are critical numbers. It's found at either those spots or at the endpoints. So what I'm going to do is say, well, if that's h, what's the derivative of h? Well, I went ahead, since I knew what f was, and I'm going to have to simplify this, I'm going to go ahead and take that f value and plug it in. So they're going to constantly do that, guys. They're going to give you an f, and you're going to be tempted just to write f prime. But take the f and plug it in there and take your derivative. So the derivative of h is the derivative of x, which is 1, is the derivative of the integral. Well, what do you have there again? Second fundamental theorem. The d dx and the integral cancel. The 0 goes away. I take the x and I plug it in, which gives me g of x, and I take the derivative of x, which is 1. Guys, make sure, if that's a 5x, you take the derivative of 5x, which is 5. Or a 4x squared, take the derivative of that, which would be 8x. Make sure you put that there if it's anything other than that x. Make sure you tack that onto the end. Okay, now what's the g of x function? Well, the g of x function is what? It's this. So I can now take this and plug it in right there. Okay, now I could have plugged it in right there too if I wanted to. It's fine. If I want to plug that g of x function right in there from the very start, totally. So you could have said f of x is this, and then g of x is the 4x plus 1 to the negative 2/3 part. You could have plugged that in there all along as well. I just chose to do it here. Now, what's this whole thing doing again? I want to know where the minimum value, which is where the derivative is 0 or dne. Well, I want to know where is that 0. So I set it equal to 0. I'm going to take all of that and add it to the other side. I'm going to divide by 4. I chose to take the negative 2/3 and make it a 2/3 on the bottom. Because I don't really like negative exponents. You might. Okay. Then I am going to cross multiply. And when I did that, I got here. And then I got to get rid of that cube root. That's a cube root and that's a square. So to get rid of a cube root, I'm going to cube both sides. That gets me to here. And then get rid of a square root, I'm going to square root both sides. Now, when you square root both sides, don't forget plus or minus. You don't get plus or minuses when you cube root both sides. Those are odd. Or never when you cube anyway, or even square. But if I cube rooted this, if I were to have done that, don't put plus or minus. Only on even roots. All right, so when I do that, I get plus or minus. So what do I get for x when I subtract 1 from that? I get positive 8 minus 1, which is 7, and negative 8 minus 1, which was negative 9, and negative 9 isn't on the interval from 0 to 26, so I can omit that. So that is my critical number. I take it and the endpoints 0 and 26, and I plug them back into the h. Now, guys, this is ugly. It's not for the first one, but this is kind of a pain. I don't see AP, and granted, it wouldn't be a pain for you because you'll have a calculator, but you actually have to now say, if I plug a 0 back into my H function, if I plug a 7 back into that, and the H function is technically this right here, and the G function is the 4x plus 1 to the negative 2/3, so you can plug it in there. But you got a calculator, so you can plug 0, you can plug that in your calculator. You could, and I didn't even bother putting the G in there because when those match, all that's 0. Right? But you can plug 0 to 7 in, 0 to 26 in. There's your function. Your calculator can do all of that math. You don't have to do it manually like I did it here. You can use your calculator, and 7 minus that's going to be a -5, and use your calculator here, and that gives it 24. 26 minus that 24 gives me 2. So you don't have to worry about the manual side of things there because you'll have your calculator to do it. All right? All right. And if they tell you you can't use a calculator, you could check your work with it, but you're going to have to be able to do this algebra. But again, it's just a U substitution just like I did earlier. All right, so that's it, guys. Please continue to check and to do these. Do the best you can. And guys, listen, if you're getting half your points, if you can get half your points on these, you are easily passing this test. If you're getting 9 out of 27, because these were 27, 9 points apiece, if you're getting 9 out of 27, it's probably not a passing grade. But if you're getting I'm telling you, it's really close. If you're getting 10 out of 27, that passes sometimes. If you're getting 12 out of 27, that always passes. But when you start getting 13, 14 out of 27, there's a good chance that's a really low 4. And anything higher than that, man, if you're getting 19s and 20s, you easily have a 4. And if you're getting if you're getting 19, that's a 5 out of the 27. I think the cutoff is probably, let me think for a second. Typically, it would probably be about 18 out of 27. 18 out of 27, possibly a 17 out of 27 would be a low 5. And that's kind of how I'm going to grade these. I'm going to look at them, and I'm going to grade you like 3, 4, 5. And if you're getting a 3, depending on your points, you're getting a good solid B. If you're getting a 4 on these, you're getting a good solid A. If you're getting a 5, you're getting better than an A. So that's where you're going to get points that are greater than 100%. All right, so do the best you can on these, and we'll talk to you soon. Bye.